पहले फर्स्ट लगा दो। इससे पहले वाली है अभी, ठीक, तब तक तो हो जाएगी, बैकग्राउंड में करते रहो। Good afternoon. Today we are going to start atomic physics, right? The last chapter of class 12th for your boards as well as the IIT-JEE. So let's start with the important results, which I believe we can show the slide. Let's see the important results. Right. Slide दिखाना. Okay. Just have a look at them. These are few of the important results. You can write them. At least write this part. This is important. For your preparation, this is important. Like, for example, angular speed. It is directly proportional to square of the atomic number. Indirectly proportional to, inversely proportional to cube of the principal quantum number. There are a few of them which I would write for you. You can write down these two important results also. Just take the right hand side. Important is the right hand side. These are two more important results. This is called R naught. This is a constant value. It's a fixed value. Similarly, this is a constant value. then there is an important result of linear speed, tangential speed. You can also write it down. This is you can say that Vn is directly proportional to Z by N. The important point about this expression is that this expression of mass of the electron. Sometimes in the JEE, you are simply asked, I would not include N in this value is value 137. Sometimes they can simply ask you what is the value of C by 137. And this constant is also 2.19 10 to the power 6 meters per second. Now, there are certain results which help you in calculation, in fast track calculations in atomic physics. One of them is this. What is R? Rydberg constant. But do you know that value of R can also vary? You feel it's a constant? It can also vary. The value, all these values which I've calculated, you have taken an assumption. And the assumption is that the mass of the electron is very, very small as compared to the mass of the nucleus. That is why we assume that electron is moving around the nucleus. All these calculations are based on this presumption. That is why we do not have mass of the nucleus in any of these terms. But if you get a question, I'll give you a question like that, where mass of the nucleus or mass of the electron is comparable to the mass of the nucleus, then all these expressions, the results change. R, the Rydberg's constant. So in all the expressions, when you use R, instead of R, you use R infinity. Now, this term signifies that we are calculating the value of Rydberg's constant when mass of the nucleus is infinite as compared to the mass of the electron. And RCH is 13.6 electron volts. This is a very interesting relation. Is that clear? R infinity CH is 13.6 electron volts. Now, as I was telling you, that in all these expressions, if mass of the electron is comparable, then what would happen? In that condition, what you do is, you first of all change the value of R. Now, the value of R becomes R infinity plus 1 plus m by m. Note it down. Let's understand what this result tells you. This is R infinity upon 1 plus m by m. In this case, m is mass of the electron. And capital M is mass of the nucleus. Perfect. Now, if mass of the nucleus is very, very large as compared to mass of the nucleus of the electron, this will become infinity. the whole thing will become 0, and the value of R becomes R infinity. Right? That is the first change. So when mass of the electron is comparable, this is going to be the first change. R infinity will become R. That's one. Two, wherever you have M, you have M here, you have M here, replace M by mu reduced mass, where mu is going to be equal to mm upon m plus m. So in all the expressions where you have a small m, you can practically replace this by capital M, by reduced mass mu. Okay? Let's take down a question which will really help you. Likho, a positronium atom is a system that consists of a positron and an electron that orbit each other. Now, this statement itself is self-explanatory, right? If mass of the nucleus, say this is nucleus, and this is electron, and that's your radius. If this mass is very, very large, then electron will move around this nucleus. But if the mass of the nucleus is comparable to that of the electron, in that case, this will have a center of mass close to the nucleus. Now, what will happen is this nucleus will move, and with respect to the center of mass, this electron will also rotate. Since the nucleus, the center of mass, and the electron lie on one straight line, you can take this as one rigid rod. The angular velocity of this and angular velocity, that means the angular velocity of the nucleus with respect to the center of mass, and the angular velocity of the electron with respect to the center of mass, both those angular velocities will be same. Note it down, please. Right? If you look at this question, this also tells you a positronium atom is a system that consists of a positron and an electron. Now, interesting line, that orbit each other. Now, when I say they orbit each other, that means they are orbiting with respect to their center of mass. Now, he says compare the wavelengths. Compare the wavelengths of the spectral lines. Compare the wavelengths of the spectral lines of the positronium with that of ordinary hydrogen. Solve it. So wherever the mass comparison takes place, okay, you use a normal R, and wherever there is an infinite nucleus, you use R infinity. Now you can solve it. What is the value of R? R infinity upon 1 plus small m by capital M. Yes. Now, when I said positronium, it says consists of a positron and an electron. That means the value of the Rydberg's constant reduces to half, right? Which means we also know that energy, अगर वो energy की expression पूछता, you know that E by E infinity is R by R infinity. That means energy also reduces to right? We also know that lambda is inversely proportional to energy, or maybe energy difference. Therefore, lambda will become 2 times lambda infinity. This becomes an important tool, important question for your entrance exam. Clear? Okay? Okay. Now, let's take another situation. If I were to ask you to fill in the blank, N1, N2, total energy, kinetic energy, or I would take this as potential energy and total energy. Can you fill in the blanks? For a hydrogen-like atom, or I would say, let's take a hydrogen atom itself. That means Z is 1. Can you fill in the blanks? First of all, do you know this expression? What is the interrelation between all these three? Bolo? Yes? Can I say Kn is negative En? And can I also say Un is 2 times? Yes? What is the value here? What is the value for n equals 2? बोलो बोलो कितना होता है 10.2 और 10.4 जल्दी बोलो कितना और इज 3.4 हाँ minus 13.6 by 4 is minus ये याद होना चाहिए वैल्यूज ठीक है 13.6 इलेक्ट्रॉन वोल्ट्स 3.4 इलेक्ट्रॉन वोल्ट्स ये डबल होता है कितना हुआ minus 27.2 electron volts minus 6.8 electron volts. Perfect. If I add both of them, I get this relation. Now, first of all, let's understand. Is this result true for all cases? This is only true when your force is inversely proportional to R square. Number one. If in a question they give you a force which is not proportional to 1 by R square, I'll take a question in which we'll take a hypothetical system where force does not vary as 1 by R square, then all these expressions will change. That is point number 1. Right, Tejaswini? Point number 2 is, now in this question, this is one energy, potential energy is one energy which is frame dependent. We regard that at infinity, the potential energy is 0. यही है ना? ये नहीं, ये नहीं है. क्या है? What is the reference? एक situation लेते हैं. You will understand it. Let's take a situation. Assume, लिखो, assume that the potential energy at n equals 1 is 0. What will be the corresponding energies of both these orbits? N equals 1 and n equals 2. For them, what would be their corresponding values? करके दिखाओ. If I take n equals 1 as 0 potential energy state, सोचा कुछ? अब see, when you get a question in the exam, you have a limited time. That means your thought process in the very first attempt has to be absolutely correct. The thought process will develop by the way the question is asked. बोला जाता है ना that the solution lies in the problem itself. Now in this question he says that the potential energy of n equal 1 is 0. ये कैसे possible है? If I were to add तभी 0 होगा ना? अगर n equals 1, n equal 1 पर मैं इतनी energy extra दे दूं, कैसे? Reference को change करके. If I am assuming that u at n equals 1 is 0, इसका मतलब ये possible तभी है ना जब इसके अंदर मैं इतना value add करूंगा. Right? Do you think this will change? Kinetic energy is frame independent or dependent? Frame dependent. This will not change. This cannot change. That means this does not change. This becomes 0. What is the total value? Likho. And write the logic also. Kinetic energy will remain the same. Potential energy, by reference you made it 0. Therefore, it is the total energy which will change and the potential energy which you have changed. Right? Achha, now, when you're giving this energy, you gave energy to all the quantum numbers, not just one. That means आपने यहाँ पर भी दिया 27.2 electron volts. ये energy कितना बन गया? What is the energy here? 3.4. So this becomes your new energy paradigm. Is it clear? This is situation number 2. See, everybody knows what is Bohr's model. And everybody can remember the results of Bohr's model. So what difference or what different questions are going to come in JEE? A, they would test you whether do you know that the results which have come are based on an assumption. Now, all the students would know this result. But do we know that this is dependent when force is 1 by r square? And if F minus du by dr can be applied, only then can we use them. Or all these expressions are based on a premise that at n equals 1, we take potential energy, which is a reference, as minus 27.2 electron volts. If I change this, how things will change? Or if the mass of the electron is comparable to mass of the nucleus, how would that hypothetical system look like? So they are going to test you. J will test you on the assumption part. Numerical part will follow. Is that clear? So when I say concepts, it means you should know the assumptions which are behind those things, and if those assumptions change, how do those results change? Isliye 90% students who cram results in questions are not able to solve because they forget the assumption. And when we talk about assumptions, people think it is derivations. Important derivation nahi hai. Isme, if you remember even these results, you can manipulate them. You know small m can be replaced by mu. R we always thought was constant. It is not R, it's R infinity. अब इसी को मैं एक further और लेके चलते हैं आगे. Suppose on the same thought what we are discussing right now. Now we know what is the value of energy. Potential energy is minus 1 by R, constant by R with a negative sign. Imagine if potential energy is this expression. We change the expression. Now he says, find the radius of the nth orbit. What changes would you do and how would you solve this problem? Suppose potential energy, what would be your first step? Change it into F? Yes or no? कितना हो जाएगा force? Tick, right? This is equal to, it is moving in a circular orbit. Right? In any Bohr's model, in any Bohr's assumption, one assumption is always going to remain true, and that is the angular momentum is n times h by 2 pi. You cannot change this assumption, so this becomes your equation 1, this becomes your equation 2. Now you can solve them, solve both these equations and find the value of R. What is the value of R? क्या है? What is Rm equal to? Clear? This is one part of Bohr's model. Now we can go on to the slides and see how we can solve these questions. Okay, have a look at this. First question. If I were to say that it's a multiple choice question, more than one options are correct. What are the possible correct options? Follow? Is the first option correct? Check your results. Radius, is it directly proportional to n square? Yes or no? Yes. Second, Is the second option correct? Yes or no? No. Is the third option correct? Yes. Is the fourth option correct? It is. Potential energy is twice the kinetic energy. So the correct options will be A, C, and D. Okay. Next slide. He says the ratio of the areas within the electron orbits for the first excited state, you need the ratio of the electron orbit, area ka ratio of the first excited state to the ground state of hydrogen atom. Can you do that? Karo, try karo. Yes. The correct answer is 16:1. The option A is correct. ठीक है ना? Why? Why do you say so? Yes. Yeah. 16/16:1. Correct. Third slide. Very good. The innermost orbit of the hydrogen atom has a diameter this. The diameter of the 10th orbit will be. I think we will use the same. Yes, radius is directly proportional to n square. Radius will be directly proportional to n square. And twice of radius will be the diameter. Since ratio we are taking, so what would be the correct option? D. Yes, the right option is D, 106 angstroms. Good. Next slide. The energy of the electron in the nth orbit of the hydrogen atom is given by this. The amount of energy needed to transfer electron from the first to the third orbit is. Jaldi karke dikhao. How much energy is required? You say C. Tejaswani says the answer is C. Okay. कैसे बोलते तेजस्वनी बताओ? E1 कितना है? Yes. And what is E3 equal to? कितना हुआ? 1.5 electron volts. And we need the difference. And the correct answer is 12.09 electron. Perfect. Next question. If the binding energy of the electron in a hydrogen atom is 13.6, you know what is binding energy? The amount of energy which is required to liberate the electron. He says is 13.6. The energy required to remove the electron from the first excited state of Li+2. Lithium plus. लिथियम +2 का Z कितना होगा? Very good. When he says first excited state means N1 becomes 2 and N2 becomes, so what is the answer? .6 electron volts. So the right and the correct option is B. Very good. Next question. Tell me the ratios of the wavelengths from state 2 to state 1 transition in Li plus 2, helium plus 1, and hydrogen atom. I want the ratio. Can you tell me the ratio? The transition is same, N1 and N2 are same. So if you have to find relation, what is the relation you actually need? The relation between lambda and Z. By the way, what is the relation between lambda and Z? Who can tell me? 2 lambda is inversely proportional to Z square. So you know the values of Z, right? Tell me what is the answer? Yes. 4 is to 9 is to 36. And the option is C. Next slide. Energy E of a hydrogen atom is given by this. The energy of a photon ejected when the electron jumps from n equals 3 to n equals 2 is how much? It's a very simple question. It requires fast calculation. You already know the concept, you remember the formula. What should be the answer? Yes. Tejaswini is absolutely right again. It is again 1.9 electron volt. ठीक है ना? Simple? हो गया? Next slide. In a Bohr's model of hydrogen atom, let RVE represent the radius, the speed, and the total energy of the electron. Which of the following quantity is proportional to principal quantum number? Now, this question will require, what would it require? It would require, do you remember the formula? Let's see. The formulas I've given you, you can directly use them. देखो किसके बराबर आ रहा है? Tejaswini is again right. The correct option is D. Now, that means इस question में कोई concept नहीं था. आपको सिर्फ formula याद होना था. So if you remember the formula, you directly can solve it. So E is RV. इसको अब आप एक formula की shape में लिख लो. E is RV. Next slide. Chalo, this looks very simple. The question says the energy of a hydrogen atom in the nth orbit is represented by En. Orbit of a singly ionized atom will be. एनर्जी के ऊपर z स्क्वायर आता है ना, सिंगली आयनाइज कितना हो गया 2. यस, सिंगली आयनाइज्ड हीलियम एटम का मतलब क्या हुआ, z कितना हुआ 2 है ना, z स्क्वायर कितना हो गया 4. सो द आंसर विल बी 4En. है ना तेजस्विनी? Yes. Next question. Next slide, please. Okay, have a look at this. It says that the wavelength of radiation emitted is lambda naught when an electron jumps from the third to the second orbit of the hydrogen atom. For the electron jump from the fourth to the second orbit of the hydrogen atom, the wavelength of the radiations emitted will be. What's the answer? Right. Absolutely. Absolutely right. 20 by 27 lambda naught. Again, formula based, right? Achha, now, let me discuss a very interesting thing in, as far as it goes conceptually. What do you mean by hydrogen? When I say hydrogen spectrum, it has Lyman, it has Balmer, it has Paschen, Pfund. Visible part कौन सा होता है? Balmer, right? So Balmer series is the visible part of the spectrum. Okay. Now, Balmer series is also represented by H alpha, H beta, H gamma series. Like for example, if he says find the wavelength of H alpha, okay, let's understand. This is N1, this is 2, this is 3. What is the value of 1 by lambda? It's R infinity CH 1 by N1 square minus 1 by N2 square into Z square. मैंने बताया था ना, RCH is nothing but 13.6. यही होता है. ये कुछ गड़बड़ है. Is there something missing? Is this the value of 1 by lambda? Is something missing or is it correct? I want you to check it. Yes, Tejaswini. है ना? What is missing in this case? देखो, आप बताओ पहले. Let me see. Is this one by, see, is this correct? And what is equals? So that means E by HC will be. So that means if I divide this by, इसको मैं नीचे ले आऊं, this should become 1 by. So this is the correct result. Understood? ठीक. ये स्टूडेंट्स मिस्टेक करते हैं, इसलिए मैंने आपको लॉजिक बता दिया किस तरह से करते हैं. नाउ इफ आई वांट द H alpha, H alpha का मतलब पता है क्या होता है? क्या लिखोगे आप? 1 by lambda h alpha is r infinity 1 by 2 square minus 1 by this is h alpha. What is h beta? 4 to 2. One by 2 square minus 1 by 4 square. Perfect. Next slide, please. Okay. Have a look at the question. When an electron in hydrogen atom is excited from the 4th to the 5th stationary orbit, the change in the angular momentum of the electron is how much? Angular momentum is nh by 2 pi. Only the value of n will change. करके दिखाओ. कितना आ रहा है? C 1.05 10 to the power minus 34. आपका भी C आ रहा है? दोनों का सही आ रहा है तो फिर गलत कैसे हो सकता है? Right option is absolutely right, is C. Great. Next slide. In hydrogen atom, if the difference in the energy of the electron in n equals 2 and n equals 3 orbits is E, what is the ionization energy of the hydrogen atom? Solve it. What do you think is the significance of this question? Whenever you get a problem in atomic physics, in JEE, if they don't mention the energy of the first state, do not take that energy as 13.6 electron volts. You take it as something as a constant. एक वैल्यू को कांस्टेंट ले लो. समझ में आया बात? हाइड्रोजन एटम की बात कर रहा है तो Z तो 1 हो ही गया. Correct option is B. तो जिस तरह से तेरे सारे सवाल ठीक हो रहे हैं, इमेजिन कर जेई के दिन भी ऐसे हो जाए. ऐसा नहीं होता. अब फिर अभी ऐसे क्यों हो रहा है? राइट, तब टेंशन होती है. तो उसका मतलब टेंशन जब होती है तो तुम्हारा पेपर खराब होता है. तो मतलब टेंशन नहीं लेनी है. See, it's just an examination. And you will have so many examinations in your life. If you start taking the stress of every examination, तो पूरी life stressful हो जाएगी. If you have intelligence, which you have worked hard, You understand things. Just be yourself. Just be yourself. ऐसे ही सोचो कि एग्जामिनेशन हॉल में बैठे हो आप. If the same thing goes, you're going to get full out of full marks. तो पूरे मार्क्स आने 120 में 120. क्यों टेंशन ले रही है? चल, next question. In Bohr's model of hydrogen atom, the ratio of the periods of revolution of an electron in n equals 2 and n equals 1 orbits is how much? Did I give you the expression for time period? Formula याद है आपको? Check करो. How does T vary with n? Check करो. Result. लिखाया था मैंने आपको. क्या लिखा था? What was T? How was T dependent? T is directly proportional to n cube. होता है ना? So if T is directly proportional to n cube, so what will be the ratio? 8:1. Correct? So the right option is, now what happens is generally exam में लोग इसको derive करने लगते हैं, and that is where they kill time. You have to remember certain results. ठीक है? Next slide. In a doubly charged lithium atom is equivalent to hydrogen whose atomic number is 3. The wavelength of required radiation for emitting electron from the first to the third Bohr's orbit will be how much? Now see, in this question, hasn't he mentioned that the ionization energy of hydrogen is 13.6? So that means you don't have to take any other value. करके दिखाओ. You remember the formula? You remember 1 by lambda is R infinity, right? 1 by n1 square minus 1 by n2 square. याद है ना? Into z square. क्या आंसर आ रहा है? कैलकुलेशन को फास्ट करो. स्पीड अप. What is the closest result? क्या है? Closest क्या है? कैलकुलेशन बहुत ज्यादा है. I don't think so. So fast करो. Is it the D option? Close आ रहा है D के? Yes. Yes. Next slide. Okay, we can leave this. Let's go on to 16th. We have very less time. Have a look at this question. Interesting. थोड़ा different thought है इसके अंदर. In this case, says hydrogen atom emits blue light when it changes from 4 to 2. 5 to 2 per, if it was a blue light for 4 to 2, what the color of the light would be from 5 to 2? सोच के बताओ. Now in this question you practically don't have to write it. सोच के बताओ मुझको एक बात. Visible spectrum clear है with Gyor? है ना? Now when you jump from 4 to 2 or you jump from 5 to 2, पहले मुझे बताओ एनर्जी डिफरेंस ज्यादा किसमें है? पक्का लैम्डा कम हो गया. If the energy difference is more, then lambda is less, and if lambda is less, you move towards left. So अगर blue था तो क्या आएगा? Violet. So the right answer is D. So in entrance exam you can also have questions like this. Clear? Next slide. Have a look at this. A single electron orbits in a stationary nucleus of charge this. It requires 47.2 electron volts to excite electron from the second to the third Bohr orbit. What is the value of Z? You can assume 13.6 electron volts as your ionization energy. What is the answer? Approximate कितना आ रहा है? What is Z square equal to? Approximately 25. Z कितना आ रहा है? 5. Yes. Very good. The right answer is 5. Absolutely fantastic. Achha, we'll have to go back to the first slide. I gave you 2 mind maps, right? Second mind map को देखेंगे अब दोबारा ध्यान से. Next slide. इसके अलावा next, इसको ध्यान से देखो. थोड़ा इसको zoom कर सकते हैं? थोड़ा zoom करिए. Okay. Let's see. पहले ऊपर वाला फॉर्मूला नोट करो. It's interesting formula. लिखो. It actually tells you that if electron has to shift from one orbit to the other, then the corresponding value of lambda is how much? आप ये लिखो. Lambda equals, write the second one, n1 square upon 1 minus n1 square by n2 square into r. ये लिखो आप. Right? अब इस रिजल्ट का एडवांटेज देखो आप क्या है. ये लैम्डा आ गया. Remember this result. ठीक है? Now, suppose I come to the Lyman series. ठीक? Tell me one thing, even in this formula, if I were to ask you maximum wavelength ट्रांजिशन किसी सीरीज का, सपोज लाइमन की बात करो, तो n=1 से n2 का क्या वैल्यू होगा जब वो वेवलेंथ मैक्सिमम होगा, है ना? जब एनर्जी डिफरेंस मिनिमम होगा। तो एनर्जी डिफरेंस मिनिमम कब होगा? जब 2 पे जाएगा। एंड इफ आई वर टू आस्क यू व्हाट विल बी द मिनिमम वेवलेंथ, n2 will become infinity. So now this expression can be remodulated into lambda max and lambda minimum. इसकी वैल्यू लिखो, लैम्डा मैक्स की वैल्यू लिखो, एंड लैम्डा मिन की वैल्यू लिखो, राइट? सो इफ यू रिमेंबर दिस एक्सप्रेशन तभी हो जाएगा, ये दोनों निकाल लोगे आप, ठीक है? नाउ अगर जेई के अंदर आपको कोई भी क्वेश्चन आ रहा है, सपोज वो कहते हैं हमको बताइए कि बामर सीरीज में what will be the ratio of the maximum to the minimum value? रेशियो भी लिख लो आप इसकी, लैम्डा मैक्स टू लैम्डा मिनिमम। हाउ मच इज इट? वैल्यू कितनी है? n+1 होल स्क्वायर अपॉन 2n+1। परफेक्ट। अब आप देखो, सपोज वो कहता है लाइमन सीरीज का मेरे को ये रेशियो बताओ, फिल इन द ब्लैंक्स। n का वैल्यू क्या लेंगे आप इसके अंदर? व्हाट इज द वैल्यू ऑफ n यू विल टेक? n1। n1 का मतलब, लाइमन का मतलब n1 कितना हो गया? 1। कितना हो गया? 1+1 कितना हुआ? 2 का स्क्वायर कितना हुआ? 2n+1 कितना हुआ? खत्म, आंसर। दिस इज अ मैजिकल रिजल्ट विच यू शुड रिमेंबर। डायरेक्ट वैल्यूज इसमें आ जाती है। अब सपोज पाशन की बात करते हैं, लेट्स टॉक अबाउट द पाशन सीरीज। निकालना जरा, ठीक है? नाउ लेट्स गो बैक टू द स्लाइड नंबर 19। अब इस क्वेश्चन को करना, इसके नेक्स्ट 19th, आई सेड 19th, यस, करना है इसको। फर्स्ट स्लाइड मींस n2 1, आई मीन n2 नेक्स्ट वाला। लाइमन का n2 कितना हो जाएगा? 2। बामर का n2 कितना हो जाएगा? 3। करो, कितना? व्हाट इज द आंसर? Yes, the right answer is 5/27. Clear? Next slide. ये अब आप कर लोगे, ये तो हो गया। Next 21. Okay, have a look at this. Hydrogen, deuterium, singly ionized helium, and doubly ionized lithium all have 1 electrons around the nucleus. He says consider n=2 to n=1 transition. The wavelengths of the emitted radiations are λ1, λ2, λ3, λ4 respectively. Then approximately what their values are. अब इसको अटेम्प्ट कैसे करोगे आप? व्हाट इज डेल्टा इक्वल टू एच सी बाई लैम्डा? तेजस्विनी, एच सी बाई लैम्डा। अच्छा, और डेल्टा ई डायरेक्टली प्रोपोर्शनल टू जेड स्क्वायर होता है। दैट मींस एच सी बाई लैम्डा इज डायरेक्टली प्रोपोर्शनल टू जेड स्क्वायर। कैन आई से लैम्डा जेड स्क्वायर इज कांस्टेंट? अगर ट्रांजिशन कॉमन है सबके बीच में, तो कैन आई से लैम्डा इंटू जेड स्क्वायर इज कांस्टेंट? लिखो. सो इफ योर लैम्डा इंटू जेड स्क्वायर इज कांस्टेंट, फिर तो आंसर आ गया. इस तरह से माइंड को फास्ट करना है, जल्दी जल्दी चलाना है. दैट्स हाउ यू हैव टू वर्क. क्या आंसर आता है? आंसर ऑप्शन इज लैम्डा इंटू जेड स्क्वायर कांस्टेंट है. अच्छा एक बात बताओ, हाइड्रोजन और ड्यूटेरियम, इन दोनों में जेड की वैल्यू कितनी है? हाइड्रोजन, व्हाट इज हाइड्रोजन? H11. एंड व्हाट इज ड्यूटेरियम? पता है आपको क्या होता है? H21. ये होता है ना, दोनों में एटॉमिक नंबर सेम है. हाँ या ना? अब जरा चारों ऑप्शंस देखना. इन दीज फोर ऑप्शंस, which are the two options which have lambda same? A and D. So the answer is between A and D. Agreed? Now either it is A or it is D. Now tell me, if it is Z square, helium is Z equals 2, तो ये 4 होगा ना? तो कौन सा ऑप्शन हुआ? खत्म. करने का जरूरत नहीं है. डोंट हैव टू थिंक, डोंट हैव टू सॉल्व अगेन एंड अगेन. सिंपल चीजें हैं, बिल्कुल बिल्कुल सिंपल. व्हेन द ऑप्शंस आर गिवन, प्लीज हैव अ लुक एट द ऑप्शंस आल्सो. उसी में आंसर निकल जाता है कई बार. नेक्स्ट ऑप्शन, नेक्स्ट क्वेश्चन पढ़िए. Hydrogen atom in its ground state is excited by radiation of wavelength 975 angstroms. Now we're going the reverse way. We are saying that if you absorb so much, if the absorption is this much, what would be the emission, or how many lines of emission spectrum will be seen? ये क्वेश्चन ये है. करना जरा इसको. In the ground state, from the ground state, you get this much of wavelength. How many lines will be present? I'm not there, no? करिए. आप मुझे बताओ, 975 एमस्ट्रॉन्ग्स लेने के बाद ये N1 से कहां जा रहा है? N2 क्या होगा? You have the formula. You know what is 1 by lambda equal to? कितना रहा N2? फोर, 3, 2, क्या रहा है? N2 4 आ रहा है, 3 आ रहा है. Okay. N2 comes out to be 4. ठीक है? Now tell me, if N2 is 4, how many spectral lines will be there? How do you find out? 10. The formula is n into n minus 1 by 2. लिखना n into n minus 1 by 2. The number of spectral lines when electron from higher orbit falls to n equals 1. कितना होता है? n into n minus 1 by 2. कितना हुआ? 6. That's the right answer. C. 6 is the right answer. Great. 23rd. अब जो क्वेश्चन आपने अभी किया, देखिए सिमिलर क्वेश्चन नहीं है. Instead of the wavelength, he has given you energy. Similar question. We can solve it. Yes. So we'll leave it. Maths का option था तो this option is C. The correct option was C. So when you go back home, please do it again. Do it on your own. 24th. Do you know what is the wave number? 1 by lambda. इसको छोड़ सकते हैं, बाकी सब कुछ वही है. Similar question. Next. ये अच्छा सवाल है, करके दिखाना. 25th question. He says in a hydrogen-like atom, electron makes a transition from energy level with quantum number n to another quantum. The frequency of radiation is proportional to how much? ये करके दिखाइए. You have to tell me. जो रेडिएशन होगा उसका फ्रीक्वेंसी किसके प्रोपोर्शनल है? क्या रहा थे जैसे? The first table I gave you, there was a relation between the frequency and the principal quantum number. देखना जरा. Just have a look at that expression again. क्या था? What was frequency dependent on? Absolutely. Inversely proportional to n cube. अब ट्राई करो. अच्छा एक बात बताओ, ये n वेरी वेरी लार्ज एज कंपेयर टू 1 का क्या सिग्निफिकेंस हुआ? जो डिफरेंस है वो ऑलमोस्ट नहीं समझे बात. He says if n is very very large, absolutely. So what will be the answer? D or C? फ्रीक्वेंसी तुमने क्या लिखा अभी? इनवर्सली प्रोपोर्शनल टू 1 by n क्यूब. तो क्या होगा आंसर? 1 by n क्यूब. हाँ है ना? यस. नेक्स्ट 26th. Have a look at the question. 23rd question. A photon of energy 12.4 electron volts is completely absorbed by a hydrogen atom initially in the ground state so that it is in the excited state. The quantum number is. Now, what's his name? What is the boy's name? Okay. Now, please understand, beta, that when I've given you the energy of the photon, okay, now the energy of the atom in the ground state is minus 13.6 electron volts. Can I get that question back? 23rd, right. He says a photon of energy 12.4 electron volt is completely absorbed in the ground state. Now, in the ground state, the energy is minus 13.6 electron volts. I'm giving it an additional energy of 12.4 electron volts. So the total energy it has is minus 13.6 plus 12.4, which is minus 1.2. Now, if I have energy of 1.2 and my energy in this first level is 13.6, I can find out the value of n. That comes closer to option C, which is n equals 4. Okay. Next. तेजस्विनी, इससे पहले वाला क्वेश्चन लेना, इससे पहले प्रीवियस 25th, इस क्वेश्चन को दोबारा पढ़ो और फिर 26 पढ़ो और फिर मुझे बताओ कि 25th में आपने मिस्टेक क्या करी है. ये फ्रीक्वेंसी किसकी है? आप अपना वो चेक करो टेबल. F क्या था उसके अंदर, उस टेबल के अंदर? What was the F? How did he define F? क्या है ये फ्रीक्वेंसी? करेक्ट. और आपने क्या निकाला है अभी? जब इलेक्ट्रॉन ट्रांजिट करता है तो वो किस फ्रीक्वेंसी की रेडिएशन एमिट करता है. तो दोनों अलग अलग चीज हैं. क्लियर? That means when you come back to this question number 25th again, please see what is he saying. In a hydrogen-like atom, electron makes transition from an energy level with quantum number n to another quantum number n minus 1. The frequency of radiation emitted. It is not the frequency with which electron is rotating around the nucleus. आप करके दिखाओ मुझको. How would you solve it now? This is frequency with which electron moves round the nucleus. And this frequency is the frequency of the emitted photon. Find out the difference and tell me the answer. Now tell me, Tejaswani, how is frequency of the emitted radiation dependent on n? Fantastic. Tejaswani is right. This frequency is directly proportional to 1 by n square. Right? Karo ab, solve karo. So what would I write? F is directly proportional to 1 minus n minus 1 square minus 1 by n square. Correct? I purposefully wanted you to get confused and you got confused. Are you clear now? Yes. What is the answer now? You have to take n greater than 1. So you can neglect the calculation. कितना आ रहा है? The correct option is D, 1 by n cube. Are you Tejaswini? Very good. 26, sir. Right? Now, if you compare this question with question number 25, he says the frequency of revolution. Now, this is F naught, which is directly proportional to 1 by n cube. और जो इसका second part है, वो आपने अभी solve किया है. वो क्या relation आ रहा है? Proportional to 1 by n cube. Yes or no? So what is the right answer in this case? D is the right answer. Clear ba? So that was a significance to give you question number 25, followed by a question number 26, so that you can understand the difference between the two results. अब जल्दी जल्दी करते हैं जरा. 27th. Have a look at this. Fast track. Don't solve it. Tell me, can you do it or you can't do it? हो जाएगा. The shortest wavelength अभी किया आपने. Lambda minimum, lambda maximum निकाले है ना? Babel series हो जाएगा. आंसर क्या आ रहा है वैसे इसका? Great. Answer is B. 28th. चेक करो. ये आपने थोड़ी देर पहले सवाल ऐसा लैम्डा का रिलेशन निकाला है. He's changing the values of z. Yes or no? Did we find out lambda z square is constant? Yes or no? Can we solve it? What should be your answer? बता दो सामने आपके. जब ये लिथियम की बात कर रहा है तो 9 तो आएगा ही ना. अगर ये लिथियम की बात कर रहा है तो 9 आएगा. 9 किस में आ रहा है? सी. तो क्यों सोच रहे हो उतना? चारों ऑप्शंस को भी देखा करो सॉल्व करते वक्त. क्लियर? नेक्स्ट स्लाइड. 30th. 29. अच्छा चेक करो. हो जाएगा ये. Wavelength of the first line of the Lyman series. The wavelength of the first line of the Lyman series 10 times ionized for 10 times ionized sodium atom is. Z कितना हुआ? Z कितना हुआ? 11 हुआ ना? If I say 10 times ionized, what does it mean? What will the value of atomic number? एक तो चाहिए ना आपको कम से कम. तो 10 बार आयोनाइज के तो Z का वैल्यू कितना होगा? 11 होगा ना? Yes or no? लिखो इंपॉर्टेंट है ये. 10 times ionized atoms. Students go wrong in this. They feel Z is 10 in this. Z is 11. And we know that wavelength is inversely proportional to Z square. Yes or no? Lambda Z square constant होता है, पता है हमको? That means the correct answer in this case is D. Perfect. Next, 30th. Check करो, जल्दी करो. Have a look at it. You don't have to solve it. Just tell me, can you do it? Relation निकाल लेंगे आप? You know the relation of lambda? You know the relation of lambda? Can you find the relation of frequencies? मिल जाएगा ना? देखो, next, 31st. Check करो. An atom emits a spectral line of wavelength lambda when electron makes a transition from E1 to E2, which expression clearly relates lambda E1 and E2. Solve हो जाएगा ना? It's a simple relation. हाँ है ना? हो जाएगा. 32nd. Check करो. A stationary hydrogen atom of mass m emits a photon corresponding to the first line of Lyman series. You can solve it. So I have with me a lot of questions, but we have a limitation of time. I'm going to discuss, since these questions remain with you, right? I think you send them now. All these questions are sent to them. Perfect, huh? Fantastic. You have these questions. You know the concept now. One important concept which I want to discuss was very, very important is likho, atomic collisions. Atomic collisions. ठीक है. Okay. एक क्वेश्चन लिखिए आप पहले. There are two atoms, or there are two particles. Say this is a neutron. It has a certain kinetic energy and a certain velocity v. This is a hydrogen atom. At rest. Perfect. Now, the question is, if the kinetic energy of this neutron is the values 14 electron volts, 20.4 electron volts, 22 electron volts, or 24.18 electron volts, 4 cases, he's asking you what would be the nature of collision in all the 4 cases. Now, when I say nature, I am saying pure elastic, I am saying inelastic, and I am saying pure inelastic. Let's understand this. Okay. Now, tell me kids one thing, girls. एक न्यूट्रॉन है, वो हाइड्रोजन एटम को कोलाइड करता है, ठीक, इतनी एनर्जी के साथ आता है. अब if neutron has to hit a hydrogen particle, if it does not lose energy, that's one case, pure elastic collision. It loses all its energy, pure inelastic. Incorrect. That is one concept which students wrongly understand. Let's first understand. Do you agree they have same mass? Tell me one thing, if there are 2 particles, one at rest, the other same mass, traveling velocity v, what is the maximum loss of kinetic take place? Let's find out. I'll give you a beautiful result. इसको याद करो. Loss in kinetic energy is equal to कितना होता है? Anybody knows this? Half mu v relative whole square. इसके आगे ये भी होता है 1 minus e square. Now for pure elastic collision, okay, E is 1, delta K E becomes 0. For pure inelastic collision, E becomes 0. Your delta E or delta KE becomes half mu v relative whole square. Okay? Now in this case, mass is also same. Now this mu is basically reduced mass. It's m1 m2 upon m1 plus m2. If both the masses are same, mu की वैल्यू कितनी हो जाएगी? m square by 2m, m by 2. ये कितना आता है? Half m by 2. Now v relative is the velocity of one with respect to the other. Second तो रेस्ट पर ही है, तो ये कितना हो गया? अच्छा बाय द वे ये क्या है? K naught. If I take this as K naught, तो भाई साहब लॉस कितना हुआ? If there are 2 particles, interesting, very interesting in mechanics and in atomic physics, the maximum loss which a particle can undergo if it collides with another mass, similar mass at rest, is max is K naught by 2. ठीक है? Now, ये न्यूट्रॉन है, ये हाइड्रोजन एटम है. अगर प्योर इलास्टिक कोलिजन होती है तो जो लॉस होगा वो 0 होगा. दिस गोज फॉर इलास्टिक, प्योर इलास्टिक. अगर प्योर इलास्टिक होगा, k naught by 2 होगा. This will be pure inelastic collision. लिख ही देता हूं इससे अच्छा. Pure elastic, pure inelastic collision. Perfect. अब जरा पहला केस देखते हैं. अच्छा, ये कोलिजन हो इसके लिए लाए so that when atoms hit each other they can transit to the next level. Next level के लिए एनर्जी लेवल्स क्या है? What is the energy difference you need? डेल्टा ई बताना. बोलो बोलो. पॉसिबल एनर्जी लेवल्स कितने होंगे? It doesn't transit zero. First transition minus 13.6. What is second? 3.4. Difference 10.2. Yes or no? तेजस्वनी समझ में आ रहा है तेरे को? 1 से 2 में ट्रांजिट करने के लिए ये एनर्जी डिफरेंस चाहिए ना. 1 से 3 में ट्रांजिट करने के लिए कितना एनर्जी डिफरेंस चाहिए? ये लिख लो आप अप्रोक्सीमेटली. फोर्थ भी लिख लेते हैं. चलो फाइनल कितना चाहिए? ठीक है. लेट्स कम बैक हियर. ये कितना एनर्जी है? 14. ठीक. आइदर इट डजंट गिव एनी एनर्जी, it stays in the first orbit, it remains the pure elastic collision. और मैक्सिमम कितनी दे सकता है ये? इसका आधा. वो कितना हुआ? और मिनिमम चाहिए कितना? तो इसका मतलब इनइलास्टिक कोलिजन, प्योर इलास्टिक कोलिजन नहीं हो सकता. प्योर इलास्टिक कोलिजन हो सकता है. लिखो 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 लिखो. Interesting now? It's an interesting thought. Okay. Right, girls? अब इसके बारे में बात करते हैं. It doesn't lose any energy. Can remain in the first orbit. Pure elastic is possible. इसका हाफ कितना हुआ? Possible. That means a pure inelastic collision is also possible. ठीक. What about this? ये कितना हुआ? क्या मतलब हुआ? What is the maximum loss it can undergo? 11. चाहिए कितना? क्या मतलब हुआ इसका? Possible है? Is this transition possible? सोच के बताओ. Take your time. And then tell me about this also. Think. We're not in a hurry. अच्छा, अगर ये परफेक्टली इनइलास्टिक कोलिजन होता तो ये केस होता ना. अगर ये केस है तो इसका मतलब परफेक्ट इनइलास्टिक कोलिजन नहीं होगा. इनइलास्टिक कोलिजन तो होगा. ठीक है ना? That means in this case either it will be perfectly elastic or it will be inelastic, not perfectly inelastic. Note करो. फोर्थ केस बता दो. ये कितना होगा? $12.09 हाफ. So, and perfect. There is one more concept which I want to tell you. Again, very important for your entrance exam. You know, we say that there is a hydrogen atom. Right? Say it releases a photon. They can ask you, what is the recoil speed of the hydrogen atom? What is the recoil speed of the hydrogen atom? Okay. Do you agree that the linear momentum of the system has to remain conserved? Do you agree? अब एक फोटोन जब बाहर आएगा तो मोमेंटम कितना लेके आएगा? h by lambda. If mass of the hydrogen atom is m and velocity is v, can I say mv will be h by lambda? लिखो. ठीक है? Perfect. Now suppose I say, तो v के वैल्यू कितना आ गया? लैम्डा गिवन होगा आपको, मास ऑफ हाइड्रोजन एटम नोन, प्लैंक्स कांस्टेंट, और इस तरह से आप इसको सॉल्व कर सकते हैं. ठीक है. ओके. नाउ लेट्स गो ऑन टू न्यूक्लियर फिजिक्स. स्लाइड्स बनाना जरा. बाइंडिंग एनर्जी कर्व, डायरेक्टली हम इस पे आते हैं. इससे पहले मैं आपको, डू यू नो व्हाट इज बाइंडिंग एनर्जी बाय द वे? पता है आपको? एक न्यूक्लियस की बाइंडिंग एनर्जी होती है, एक रिएक्शन का बाइंडिंग एनर्जी होता है. यू नो व्हाट इज बाइंडिंग एनर्जी ऑफ अ न्यूक्लियस? लिखो. Suppose I take a nucleus is equal to number of neutrons, protons, या neutrons ले लेते हैं, plus minus is this fine? This is the binding energy of a nucleus. ठीक है ना? Clear? Second thing in which this is the stability graph. बनाओ. You know, if I take the number of neutrons here and number of protons here, the curve goes like this, and after some time it bends like this. लिखो. This value is A equals 40. We say here n is equal to P and here n is greater than P. Now, inside a nucleus, there are many forces which are operating, but there are two primary forces. One is a nuclear force, which is a short range force. B, a very strong force. D, attractive. E, independent of charge. Also, you have Coulombian force. Charge dependent. Inside the nucleus, you have protons and neutrons. Protons have a positive charge. So there can be a strong Coulombian repulsion. Now, if you see this graph very carefully, there are certain important points I want to tell you. The binding energy graph. इसको बहुत seriously लोग लेते नहीं है, इसको थोड़ा seriously देखते हैं. Do you realize that when the mass number is low, it suddenly rises? What do you mean by binding energy per nucleon? समझो बात को. There is a nucleus. There are protons and there are neutrons. As far as nuclear forces are concerned, it doesn't bother whether they are positive or they're neutral. They are independent bodies which can attract each other. अब problem क्या होता है? One nucleon is surrounded by other nucleons. अब एक न्यूक्लियन, ध्यान सुनना, के साथ एक दूसरा न्यूक्लियन आया. Now binding energy per nucleon means this single nucleon, how much close or what is the force which this attractive force which this nucleon applies on this nucleon. अब शुरू में क्या होता है, जैसे जैसे न्यूक्लियन ऐड होते चले जा रहे हैं, बाइंडिंग एनर्जी या स्टेबिलिटी बढ़ते जा रही है. अट्रैक्शन, सब मोर द अट्रैक्शन मोर द स्टेबल. जितना सिस्टम रिपल्सिव होगा उतना वो अनस्टेबल होगा. So that means when I have a single nucleon, now binding energy per nucleon means एक न्यूक्लियन के साथ एक आया, फिर दूसरा आया. तो शुरू में जब मास नंबर कम होता है, कम न्यूक्लियंस होते हैं, this increases very fast. Then what happens? Now अब क्या हुआ? This is one nucleon. एक एक न्यूक्लियन यहां पर सेट हो गया. There is an effect called saturation effect. After some times, when the second layer has to come, now this nucleon of the second layer is not attracted to this nucleon. That means after a certain time, when you keep adding the nucleons, the binding energy of this single nucleon is not going to change. Likho. So that means in this period, this surge is because every single nucleon is getting attracted by one single nucleon. But in this stage, in this period, because of the saturation effect, the change in binding energy per nucleon, it does not increase, it doesn't change. Okay. अब आप देखो इसका थर्ड पार्ट. अब ये फॉल क्यों हो रहा है? Two forces, attractive, Coulombian. Nuclear forces are short range forces. तो जब एक सिंगल न्यूक्लियन के पास दूसरा न्यूक्लियन आया, अफेक्ट ज्यादा आया. Coulombian forces are long range forces. अब जब बहुत सारे न्यूक्लियंस हो जाएंगे, तब Coulombian force will come in play. अब रिपल्शन का इफेक्ट भी आएगा. But since nuclear forces are very strong, as compared to Coulombian forces of repulsion, the effect of nuclear attraction is more than Coulombian repulsion. So there is a fall, but the fall is not steep. It is gradual. Now, since you girls are not left with time, what we'll do is, maybe I'll have to take one more session, or we'll have to do something about it. I'll be needing 1.5 hours more. या फिर what I can do is I can give you these notes, I can give it to you, I'll give you the questions, you can go through them. एक बार जरा slide change करना वैसे. Next slide. Next. Try करोगे इसको? Can you do that? Can you do it? Momentum conservation. Yes. एक बार बहुत जल्दी से, I'll just take 5 minutes. I'll give you some basic formulae which you ought to remember. लिखो फटाफट. In the next 5 minutes, I'll give you the formula. First of all, there is something called the Q energy. Let's understand. Q energy comes, these questions come under the category of nuclear reactions. Like for example, there is kinetic energy of the, I represents incident particle, okay? Capital I is the incident particle. Now, you do agree in nuclear physics, mass also is energy and kinetic energy is also energy. So whenever we talk about energy expressions, we have mass as well as its kinetic energy. तो ये भी एक energy का source है. I represents the incident particle. This is kinetic energy of the incident particle. They form a product. P is product. O, then you can say Kp is the kinetic energy of the product. T is the target. Okay. I'll also have a O and a KO. Incident becomes P, okay? Target becomes O. Outcome लिख सकते हो आप इसको. Now, Q is basically, ध्यान से देखना, is Kp plus Ko minus Ki. ठीक? This can also be written as, ये है किसके बराबर? Mass of incident particle, mass of target minus mass of product plus mass come into C square. This is called Q value. ठीक है? If Q is positive, it is called exothermic reaction. ठीक है? Okay? Now, if Q is negative, if Q becomes negative, इसका मतलब ये हुआ that you need to have a threshold value of energy or threshold energy to initiate a process. ठीक? The value of threshold energy, वो भी लिख लीजिए आप. K threshold is M plus M by capital M into mod of Q. I'm using a mod Q because Q will be negative, so I need the mod value. This is the threshold value. Okay, इस expression में Q का value है वो भी लिख लीजिए. is K naught minus Ki ठीक. This energy is in the ground frame. Three more minutes. मेन प्रोसेसेस होते हैं, एक होता है अल्फा डीके, फटाफट लिखो. इसका प्रोसेस क्वेश्चन लिख देता हूं मैं. ठीक लिख रहा हूं. O2 K alpha plus Ky. Spontaneous process. A nuclei disintegrates into a product. Okay, product is Y. इसमें, if I have to find the value of K alpha, this is A minus 4 by A into Q. Your Ky is 4 by A into Q. ये values याद कर लेना. K is kinetic energy of the alpha particle. Okay, and Y kinetic energy of the residual. Q का वैल्यू लिख लीजिए, will be mx minus my minus m alpha, इसका मास, into c square. फिर आता है बीटा नेगेटिव डीके. I'll write the process equation for you. Proton, or you can say it's a parent. A parent disintegrates into a daughter. It comes out with an anti-neutrino also. ठीक है, इसका Q वैल्यू लिख लीजिए. दो इक्वेशन और रह गई. बीटा प्लस डीके, parent, daughter, positron, and a neutrino. This is a neutrino. इसका Q वैल्यू होता है, वो भी लिख लो आप, mp minus md minus 2 times mass of the electron into c square. And finally, electron capture. Parent, it captures its all orbital, अपने ही इलेक्ट्रॉन को ये कैप्चर कर लेता है. Daughter and a neutrino. इसका Q वैल्यू आता है we could somehow manage it. ठीक है, the questions you will get from my slides, you will get those slides, see them, and all the best. We could finally complete this also. Thank you.